Good day everyone, I am Manuel L Cuarez from BSEMT 4P3 and me and my fellow researchers are here to present our thesis entitled Bluetooth-based wearable social distancing bracelet.
Background and rationale. The COVID-19 pandemic has brought a lot of challenges to many people around the world since it began in Wuhan, China, and it's still an ongoing problem the world still faces today. With today's population density, the spread of disease is growing at an exponential rate all over the world, primarily because of unmonitored physical contact and travels of people. One of the traditional ways to avoid catching the illness is through maintaining social distancing.
This paper
Conceptual
discusses the
framework.
design and implementation of a Bluetooth-based wearable social distancing bracelet. These wearable devices function in groups and enable the wearers to further monitor and adjust their distance in relation to other wearers, further aiding in the implementation of social distancing protocols and slowing down the spread of COVID-19.
Problem statement: the Bluetooth-based wearable social distancing bracelet has to overcome challenges in terms of range, portability, and power efficiency. In what way should the Bluetooth-based wearable social distancing bracelet be designed? What working technological principles should be utilized and implemented to ensure that device functionality? What methods of evaluation can we use to evaluate the Bluetooth-based wearable social distancing bracelet's efficiency in relation to real-life situations?
Objectives of the study. The researchers of this project development aim to design a relatively cost-efficient, lightweight, and user-friendly social distancing bracelet prototype. To figure out the working technology principles that supports the development of these devices. To assess the efficiency of the social distancing bracelet in real-life world
Social
scenario.
distancing. Conceptual framework. As we can observe in Figure 1, the wearable social distancing bracelet work connectively with each other through Bluetooth-based transmission. These devices communicate to each other with their corresponding receiver, input and transmitter or output modules, while signal decoding and analysis are handled primarily by the ESP32 microcontroller. Furthermore, the output is then interpreted by the wearer via sensory and visual output devices such as LEDs and vibration motor or buzzer while transmitting Bluetooth signal simultaneously.
Scope and limitations of the study. The research setting will be at Cagayan de Oro City. The proposed study aims to be tested at indoor experimental setting with multiple device wearers while still adhering to the health protocols. Observable limitations. The device's working period is highly reliant to its battery capacity, and the device requires a substantial amount of time to charge its batteries. Signal barriers and interferences are also factors that can affect the performance of the device. The overall size of electronic modules and components involved is larger than the size requirement of the device, making designing difficult.
The study's overall significance is to spread awareness to all people, especially to those who are engaging in outdoor activities such as employed people, students, and etc. These devices can also be useful in monitoring people's distances to one another in indoor establishments, such as malls and schools, where space is limited and people often forget or neglect social distancing protocols. Research flow and methodology. The research flow and methodology will begin by identifying the problem, followed by idea generation and conceptualization. Next is the development and prototyping, followed by the implementation and evaluation, respectively. Here is the conceptual design of the Bluetooth-based wearable social distancing bracelet. The device is primarily composed of the ESP32 module, which handles the transmitting, receiving, and processing of data, and with capacitive sensors as our input, and also a variety of output electronic components such as OLED display, LEDs, and buzzers. Our devices will be designed in the most minimalistic manner as possible. So here is the programming flow chart of our devices. Our devices uses a simple algorithm. First, our devices initialize the necessary variables needed to and start scanning for nearby RSSI. Then, two conditions must be met in order for the LED and buzzer to activate. First, the RSSI has to be coming from a similar device. And second, the RSSI has to be less than the desired RSSI cutoff value. If both conditions are met, the Edd N buzzer will activate. If either one of the conditions are not met, the Edd N buzzer will remain off and resume.
Simultaneously. Network topology. In Figure 4 illustrates the network topology of Bluetooth-based social distancing bracelet. As seen above, the devices follow a mesh-type network topology wherein all devices are capable of communicating with multiple devices. Each device acts as a receiver and a transmitter, allowing these devices to interact with each other in two-way communication method.
Here is the circuit design for the Bluetooth-based wearable social distancing bracelet. Review unrelated literature. Ford Motor Company experimental social distancing wristbands. Enforcing social distancing by developing wearable wristbands that buzz when employees come together within 6 feet of each other. These devices utilizes Bluetooth shortwave and low-power technology to function. Social Distancing Alert System, or SDAS, based on Bluetooth Low Energy Proximity Detection technology, which uses the Received Signal Strength Indicator, or RSI, and Transmission Power, or TX power, of users' Android handsets.
Design and custom wearable devices. 6 feet apart performs wireless localization using ultra-wideband radios to determine if two or more devices are in close proximity. Can distinguish if there is a physical barrier between devices, such as wall, that would prevent the close contact. Social distancing sensor devices. Uses ultrasound and radio. This device demonstrates bidirectional communication and each device's buzzer to trigger when two units are in close proximity. Communicate with each other through both ultrasonic and radio frequency signals.
That would be all. Thank you for listening.